was.
You want to see some moves? Now you don't have to be like that. Come on and play. Look, he likes you. Don't you have time for a little one-on-one? How long has it been since you played? Come on, you got the ball. Take a shot. No, my lady, not from there. It's out of bounds. Gotta be on the court to be in play. Welcome to Duke Reginald's court of unending possibilities.
That hurt.
It never touched you.
Right.
And it's not solid. This ball is mostly empty.
We were all taught in school that the world is made of stuff, of matter, of mass, of atoms. Atoms make up molecules, molecules make up materials, and everything is made of that. But atoms actually are mostly empty. For example, if this ball were the nucleus of an atom, a proton in a hydrogen atom, for example, then the electron circling this, which would describe the outer limits of that atom, would be out by that mountain over there, roughly 20 miles away. And everything in between is empty. In fact, the universe is mostly empty. However, when we go down in scale, in the emptiness, we eventually come to a level, the fundamental level of space-time geometry, the fine basement level of the universe, where there's information, there's a pattern. It's called the Planck scale, and it's the fabric of the universe. And at that level, there's information that's been there since the Big Bang. So most of the universe, even of matter, is actually empty.
Most people think that the vacuum is empty. But for internal consistency of quantum mechanics and relativity theory, there is required to be the equivalent of 10 to the 94 grams of mass energy, each gram being E equals mc squared kind of energy. Now that's a huge number, but what does it mean practically? Practically, if I can assume that the universe is flat, and more astronomical data is showing it's pretty darn flat. If I can assume that, then if I take the volume or take the vacuum within a single hydrogen atom, that's about 10 to the minus 23 cubic centimeters. If I take that amount of vacuum and I take the latent energy in that, there is 1 trillion times more energy there than in all of the mass of all of the stars and all of the planets out to 20 billion light years. That's big. That's big. And if consciousness allows you to control even a small fraction of that, creating a Big Bang is no problem.
Organizations like NASA, British Aerospace, are all trying to tap into this incredible, unimaginably large energy sea. And they feel if they can tap this, we can travel to different galaxies. So they understand that in empty space, there is this unbelievable energy.
The major basic idea that quantum physics implies, which makes us understand this or even think about this new paradigm, the thing which is that there's this underground, there's got to be a realm of existence which cannot be ever touched on or seen, which bubbles into the existence giving rise to our understanding of the world.
The tighter physics have tried to grasp onto physical reality, to understand what it's really made of. What are the core building blocks of life at the basis of it all? Life, the universe, slips through your fingers. And you come up with something that's increasingly abstract to come to the realm of pure abstraction. And that's what the unified field is. It's pure abstract potential, pure abstract being, pure abstract self-aware consciousness, which rises in waves of vibration to give rise to the particles, the people, everything we see in the vast universe.
What makes up things are not more things, but what makes up things are ideas, concepts, information.
And like I said, it never touches.
Another strange fact is that objects never really touch each other. When I dribble this ball, the atoms of the ball and the atoms of the ground never actually meet.
So nobody touches nothing. Come on, put your stuff down. Somebody's gonna take it. Like I said, this is my court. It's no problem. How long has it been? I'd be 8.
The first inkling in physics that we got that time ain't what it seemed to be came with relativity. That was the first inkling. That time was not absolute. It was not the absolute ruler of the universe. That God Almighty did not say 1 second, 1 second, 1 second, 1 second, 1 meter, 1 meter, 1 meter. You're in a gravitational field. Your head is actually moving at a slightly faster rate than your feet.
The second law of thermodynamics says that things unwind and move forward, so that gives an arrow of time. But at the quantum world, in the micro world, the second law of thermodynamics doesn't seem to hold, and things can go backwards or be timeless.
The fundamental equations of physics have a property which is referred to as time reversal symmetry. And what time reversal symmetry means is that a set of laws which are time reversal symmetric are laws that have the following feature. For any process that's in accord with those laws, the same process going backwards is exactly as much in accord with those laws. Okay? That ought to mean that that milk jumps out of coffee as often as it dissolves into it, that people get younger looking as often as they get older looking, that we have the same kind of access vis-a-vis knowledge to the future as we do to the past, that by acting now we ought to be able to influence the past just as much as we can influence the future. All of that is wrong. All of that comes into violent conflict with the way we psychologically experience the world.
One of the most unpalatable ideas still, in spite of the fact that quantum physics has been around a long time, is the possibility or the notion that the future can have a causative effect on the present. We believe that the past can have a causative effect on the present. I hold the ball, I drop it, it falls. Cause, effect when it hits the ground. But could the ground be the cause of my dropping the ball in the first place?
It's only in conscious experience that it seems that we move forward in time. In quantum theory, you can also go backwards in time, and there's some suggestion that processes in the brain related to consciousness project backwards in time. For example, in the late 1970s, a neurophysiologist at University of California, San Francisco, named Ben Libet, did some very famous experiments. What Libet did was study patients who were having neurosurgery on their brains, with their brains exposed, while they were awake. They were given a local anesthetic to numb the area of the skull and scalp to access their brains. And they were awake, and Ben would talk to these people. So, for example, what he did was he would stimulate their little finger and look at the part of the sensory cortex on the opposite side that was related to that, record from it electrically, and ask the patient when he or she felt the stimulus on the little finger. And he would also stimulate at that particular area of cortex. Now, what you would think would be that if you stimulate the little finger, it takes a finite period of time to get to the opposite side of the cortex, so the patient would report it a fraction of a second later after the stimulus. And when you stimulate it directly, the patient would report it immediately. He found just the opposite. When you stimulated the little finger, the patient felt it immediately, and when he stimulated directly in the cortex, there was a delay. After sorting through all the data and repeating this over and over, Libet came to the conclusion that somehow the brain was projecting information backwards in time. So that it did take a finite amount of time to get to the sensory cortex, but the brain projected it backwards in time so that the conscious perception was that the stimulus was felt when the pinch actually occurred.
There have been some studies which have shown that when people are beginning to move a hand or beginning to say something, that there's actually activity in the brain in certain nerve cells of the brain even before they become consciously aware of what they're trying to do.
I know it seems to me that I often do things and then decide a fraction of a second later what to do, but I've already done them.
I agree. You can always go back in time.